Okay, so we're going to graph the parent function of a cube root, and we're going to graph the function given to us in this problem. And first we're going to write down the transformations. Okay, it looks like my window's a little messed up because earlier in one of my other classes we were needing to go down the y-axis further. Who remembers the easiest way to go back to your standard window? Zoom 6. Okay, so look, the blue is the parent function. The red is our function. So how is the red different from the blue? Over to the right 6, and then up 4. Because the center was originally at 0, 0. Isn't the center now at positive 6, positive 4? The right 6 was caused by this x minus 6 up underneath. And the up 4 was caused by this plus 4. And isn't that the only thing that happened to it? It just shifted right and up. So those are the two transformations you'll write. You'll put right 6 and up 4. Now, with cube root functions, do we have a starting point? No, but we do have a what point? A center. So right here, just cross out that and put center. With a parent function of a cube root, the center is at 0, 0. But now with this one, the center's been moved to where? Look, where's the center of this one? 6, 4. Because it shifted everything right 6 and up 4. So if it was at 0, 0, when you shift it right 6 and up 4, now it's 6, 4. Does that make sense? Okay, maximum. What's the maximum point on that function? Right. With all cube root functions, won't they go up forever and down forever? So you won't have a max or a min. Okay, where is the y-intercept for this function? 0, 2 is where it looks, but let's just check the table to make sure it's not 2 point something. So second table, we're looking for what? Where x is 0. But then it is kind of confusing because I have both graphs, but remember the blue is just the parent function, the red is the one we're looking at. So where's the actual y-intercept? 2.18. So we'll round that to like 2.2. So your y-intercept is 0, 2.2. Okay, look at that red function again. Is it going to have an x-intercept? You don't look when we go this way. Don't you think that's eventually going to come down enough to hit the x-axis? So it's going to be somewhere back here past negative 10. So if you go back to your table and go back towards negative 10, we're looking for what? Where what's 0? Y. Because if the y is 0, that means it's sitting on the x-axis. And we're getting closer. We're at 0.4, 0.3. Right there. Where was it? Negative 58? Okay. Negative 58. Okay, in behavior. Remember, within behavior, they will always write this for you. They'll write x approaches infinity, and they'll write x approaches negative infinity. Now, sometimes they'll switch it up and put the negative on top and the positive on bottom. You just have to make sure you read it. And then you'll have to fill in what y approaches. So, on this graph, keep in mind we're looking at the red one. Wow, it's still going. On the red one, what does x approach infinity mean? Well, it means right. Because the x-axis runs left and right, so wouldn't positive infinity be right? So as this function goes right, the y's are getting higher. Look, as you go to the right, isn't each y value getting higher up on the y-axis? So y's are approaching positive infinity. X approaches negative infinity means left. As you go left on the function, the y's are getting smaller. Look at the red. As you go left, aren't they going down?
Yeah.
So negative infinity. Okay, now before we do the rest, let's go ahead and get a sketch. We know our center is at 6, 4, so right 6, up 4. And then how can we find a few more points? Well, the table. So second table. And then I got to get back to something nice. But like I said, even though doing this takes a while, it's the easiest way to do it. The other way is harder. Okay, so now look, there's a nice point, but I still can't fit -8. Just put -2 on there. I mean, oh yes, thank you. Okay, so there's one, -2, 2. So left 2, up 2. And then the next nice point I see is 5, 3, 6, 4. Yeah, we already have 6, 4. That was our center. Okay, and then 7, 5. So that should be enough. I mean, you've seen the picture, so you know this is the center, and from there it goes up. Oops, I missed it. And then it goes down to the left. Okay, so now that we have a sketch, let's talk about intervals of increase and decrease. Well, first of all, from left to right, what is this function doing? Increasing. When did it start increasing? When did it start increasing? Negative infinity, right? Because left forever ago was negative infinity. When did it quit increasing? It won't ever. It'll keep going right forever, which is positive infinity. This will also be your what? Domain. Because remember, intervals always use x values. Well, isn't that what your domain is, the x values? Now, what about range? How far down could you get on this function? Negative infinity, because doesn't it keep, as it's going left, isn't it slowly dropping also? And it'll continue that forever. So it'll go down forever. How far up will it go? Infinity. Okay, number 13. Y equals negative cube root of x minus 6. Okay, so comparing that to our parent function of a cube root, what all is different about this equation? The negative. Okay, so we'll have to look at it and see what that causes. And the minus 6. Well, we kind of know without graphing it what the minus 6 is going to cause. What is it going to cause? Down 6. Does anybody know what the negative will cause? A flip or a reflect, right. Okay, so now let's graph it. Keep in mind the blue one is the parent function. The red one is the one we're looking at, so we can compare. Negative cube root, so math number 4, we'll pull up a cube root, of x, and then minus 6 on the outside. We already said we know that minus 6 is going to cause our red function to go down 6, and it did. And see how it reflected? Instead of going up from left to right, now it's going down from left to right. And that was caused by that negative out front. Okay? So instead of, this was supposed to say starting point, but do we have a starting point with a cube root? No, you have a starting point with a square root, but you don't with a cube root. But what we do have with a cube root is a center. And now that it went down 6, where is the center now? 0, negative 6. Because remember, a cube root is always going to be centered at 0, 0. But if you shift it down 6 units, it's now going to be centered at 0, negative 6. Okay, does any cube root function have a max? No, because it'll go up forever. It doesn't always have to be up forever on the right. In this case, up forever on the left, right? But it'll go up forever. Does it have a min? No, because it also goes down forever. Where is the y-intercept of this one? 0, -6. The center is also the y-intercept. Is it going to hit the x-axis? Yes, but way over here in the negatives, right? So you have to go to your table. You know it's way back in the negatives. And we're looking for what? Which one? Red. Red. So where the y becomes 0 in the red. I discovered something. You know what I discovered? If I hold it down, as soon as I let go, it stops. But if I do all the clicking, it'll like keep going even when I stop. See? So it's better just to hold it down and not click, because then as soon as I let off the board, it stops. Getting closer, getting closer. So close. There it is, -216, 0. Okay, in behavior. Before we answer these, let's go ahead and get a sketch on our graph. The center is 0, -6. And then, of course, maybe we should find our other points before we do the table. Before we go way over to the x-intercept. But like I said, even though this is annoying and tedious, it is the easiest way to find these values. Hey, Michael, will you open the window, please? Or Derek, whoever. Ow. So, second table set right there. So if I want to start at 0, that's x equals 0. The other day I tried it, but I thought I just had to hit 0 on here, but I was like, that didn't work. Okay, did y'all see that? Okay, so now I'm back at 0. I'm going to go back a little this way and try to find a point over here, which it only goes to -6. Okay, -1, -5. And then we already have 0, -6, 1, -7. And then let me go back this way a teeny bit and see if there's a nice one. Even though that won't really fit, we can make it fit. -8, -4, just to get another point over here. And then, if you have a point over here at -8, -4, where do you think you're going to have a point on the other side? 8, -8. It's going to be the same distance away, but it's going down, so it's going to be 4 units lower. So about right there. -8, -4. -1, -5. 1, -7. And 8, -8. 8, -8. Okay, so then you just do a sketch. This one's 8, -8. This one? -8, -4. Okay, so now in behavior. As x approaches infinity, what does y approach? I'm asking y'all. Negative infinity. That means as you go right, you go down. That makes sense. As you go right, you're going down. As x approaches negative infinity, y approaches positive infinity. As you go left on this function, you go up. Is it increasing or decreasing? Decreasing. From left to right, we're going down. When did it begin decreasing? Forever ago to the left, right? Which is represented with a negative infinity. How long did it decrease? Forever to the right, which is positive infinity. This will also be your domain. And then by now, we should start picking up on the fact that all cube roots have a domain and range of all real numbers. They go up, down, left, and right forever. Okay, next page. Okay, number 14. Y equals 2, and then the cube root of x plus 4. So, when you're comparing that to a parent function of the cube root, what's been changed of the equation? Right, it has a number out front, that's your slope. And it has a 4 inside, which is a horizontal shift to the left. Okay, so now let's graph it. Y equals, I'm going to leave the parent function in there, that way I have it to compare to. And then 2 times the cube root of x plus 4, and then I'm ready to graph. Remember, our function is the red one. The blue one is just what we're comparing it to. So how did ours change? Where did the center go? It went left 4, because the center was at 0, 0, and now isn't the center at negative 4, 0? Okay, so right away I can go ahead and write down that it went left 4, which put your center at negative 4, 0. Was that the only transformation that occurred? What else happened to this red one? It actually did, because look, the 0 center is 0, 0, and it's still a negative 4, 0. So it didn't go up, it got more stretched out because of that 2 in the front. Let me zoom in so you can see what I'm talking about. Okay, see how with your standard parent function of a cube root, to get from this point to the next point, it's up 1 over 1. That's because there's an understood 1 out here in front. But with ours, there's a 2 out here in front. So let me, when I zoomed in, I didn't go over enough. Anytime you zoom, let me just go back to the standard graph. Anytime you zoom, you have to hit zoom in, but then you have to move the cursor to where you're wanting to zoom into. That's why we couldn't see the red one, because my cursor was still over on the blue one. And it doesn't always have to be right on it. I think that'll be close enough to it. Well, it's still moving. That clicked. Okay, well, can you kind of see, though, how from the center to this next point, it's not up 1 over 1 anymore, it's up 2 over 1? Can y'all see that, even though I didn't really get good on the graph? That's caused by that 2. So you would write it has a slope of 2, which makes it just appear more stretched out. It's like taller. Because to get from your center to your first point, you have to rise 2 and run 1. When we normally only have to rise 1 and run 1. Okay, what about max and min? Max and min does not exist. With cube roots, you'll never have a max and min because they go up and down forever. Y-intercept. Okay, how do I get back to my normal graph, my normal window? Zoom 6. Where is the y-intercept of my function? The y-intercept. Where does that red line cross the y-axis? 0, 3, right? I'll go to the table just to make sure it really is exactly on 3. let's see, it's actually not. It's at 0.317. So we'll round it to 0.3.2. Okay, where is the x-intercept? -40. Okay, now let's sketch it. We have a center at -40. And then, without even looking at the table, look what I can do. Let me zoom in a little so you can see it better. Without looking at the table, I know since my slope is 2, the next point will be up 2 over 1, and the other point this way will be down 2 over 1. That'll be 2 of the points. Now, those are the only points that contain that slope. After that, it's not like a line. So to get some other points, we need to go to the table. Okay, so 4 is a nice one. So we can go over 4, up 4. And then let's find one back here. How about negative, well, there might not be one that fits on there. Oh yeah, I missed that one. -5, negative, oh, we have that one because, did everybody see how I knew where that one was going to be because of the slope being 2 over 1? But it looks like there's not going to be another nice one that's going to fit. The next one will be -12 down 4, so we'll just guess -12 down 4. Okay, so now we sketch. Okay, so now for end behavior. As x approaches infinity, what do the y values approach? Positive infinity. As you go right, you also go up. As x approaches negative infinity, what do the y values approach? Negative infinity. As you go left, you go down on this one. Is it increasing or decreasing? It's increasing. When did it start increasing? Right, and when did it quit? It doesn't, so infinity. This is also your domain. What's your range? Same thing. For all cube roots, they have domain and range of all real numbers. They go up, down, left, and right forever. Okay, for number 15, I'm going to give you one to try by yourself. So y equals -3. Okay, that's a big -3. And then cube root of x. Okay, try that one. This one. Without even graphing it, I can tell you some of these things. Because the only thing that's different about this function than a parent function is the -3. The negative will reflect it. And the 3 is a slope of 3. So, reflecting it and having a bigger slope does not cause it to shift left or right. Left shifts are up under the radical, or horizontal shifts occur up under, vertical shifts occur out from under. So there were no vertical or horizontal shifts, so that means your center point is still at 0, 0, correct? We know with cube roots, you never have a max or a min because they go up and down forever. Now, I know that if my center is still at 0, 0, that's also my y-intercept and my x-intercept. The end behavior. This is the first thing that you might actually want to look at the graph for. You don't necessarily have to, but remember, normal cube roots go like this and this. So if it's been reflected, won't it now go like this? But like I said, if you can't remember all that in your head, get yourself a picture of it. So y equals, our function is -3 cube root of x.
So how do you do that?
To get the cube root, you go to math and then it's number 4. Okay, so now when I graph it, there's the parent function. There's mine. See how it's now going down from left to right because it was reflected? So now the end behavior is, as you go right, you go down, and as you go left, you go up. So now is it increasing or decreasing? Decreasing. And with cube roots, isn't it always negative to positive infinity? You just have to decide which one it's doing. and that's also the domain. And the range is also all real numbers because it goes up and down forever. Now, without even looking at the table, I can tell you 3 points. I know that my center was at 0, 0 because it didn't shift left or right. It didn't shift up or down. There was nothing added or subtracted on the inside or the outside. I know by the slope being 3 over 1 that from this point, it'll go down 3 over 1 and up 3 over 1. And then to get the other points, I would need to look at the table. So if I go to the table, keep in mind mine's the red function. -8, -6, is that going to fit on there at all? I mean, we can make it. -8, -6 would be, oh, wait, that can't be right. -8, +6. -8, +6 would be about right there. And then on the right side of the graph, 8, -6. Sit down. Okay, so that's what the graph looks like. Okay, let's look at the first one. Remember remember, is this a square root or a cube root function? Is this a square root or a cube root? Square root. Because you have a starting point and then from there it goes. A normal square root function looks like this. It starts at 0, 0, has a slope of 1 over 1, and it looks like this. That's a normal square root function. So how is ours different? How many? And it also shifted right 1. Is that the only thing? Did the slope change at all? No, because look, from here, you still have to go up 1 over 1 to get to that next point, correct? So the slope is still 1. It did not change. So to write this equation, it's y equals the square root. To represent right 1, don't you put x minus 1 up underneath the root? And to represent up 2, you put plus 2. Now, what if you've written your equation and you're not sure you did it right? What could you do? Graph it. So, let me clear out everything from before. And I'm going to graph my equation that I think it is. X minus 1 on the inside, and then on the outside plus 2. Okay, now, does that look pretty much what we see on our graph? Okay, but watch this. I can get even more precise just in case you're not convinced by going to the table and looking at points. Look, 1, 2, we have a point there. 2, 3, that's a point. 5, 4, don't we have a point of 5, 4? So that lets me know I have the right equation. It matches perfectly, okay? Now let's try this one. Remember, your parent function of a square root starts at 0, 0. The next point is up at 1 over 1, and then it looks like this. So how is this one different? Where is its starting point? -2, 0. And so that means it did what kind of shift? Left 2. Did it have any vertical shifting? No. So what happened to it? It didn't go up or down. The starting point's still at 0 vertically. It's just left 2. So there was no vertical shift. What made it do this? It reflected over the x-axis, correct? Okay, and those are the only two things that happened. The starting point shifted left 2, and then it reflected over the x-axis. So to write the equation for that, it's y equals, to reflect over the x-axis, you put a negative out front, and then the square root, and to represent left 2, you put x plus 2 inside. And like always, remember, when you're done, graph that and see if it looks like the one you're doing. There's no reason to get these wrong when you can check them like that. Okay, one more and then we'll be done. Okay, remember, your parent function of a square root always starts at 0, 0, goes up 1 over 1, and looks like this. So how is this one different? Where is its starting point? Left 1. What else is different? The slope is much steeper, right? What is its slope? 3. Look, to get to this point, to the next one, don't you have to rise 1, 2, 3 over 1? So the slope is 3. Did it reflect at all? No, it's still going the same direction. So the equation would be y equals what? 3 x plus 1. Right. Okay, next Thursday when we're back, I'm going to finish up this stuff. Friday we're having the quiz. And then the next Monday we're moving on to solving, like algebra stuff. No more graphing. Okay?